Okay, so let's warm up by trying the do now. So I'd like you to try the do now, number 1 for me. All right, at this point, you've tried the do now, so let's see what we need to do here. We have a polynomial where our a value is negative, and we know that we have x-intercepts at -2 and +1, each with a multiplicity of 1. So we know we have 2 real roots. So we know that this is going to be even degree. And our end behavior should be down, down, because we had a value that was negative. Then if we look here, we don't have any information about y-intercepts, so we're just going to do a rough sketch using our x-intercepts. If we were going to write a possible equation of this, and we're saying possible quadratic, we're going to say y equals, now we know from our roots it should be x plus 2 and x minus 1. However, we know that it needs to have a negative a value, so I'm going to write -1 out here. Now, the general idea is it should be y equals some a value, in this case, times x plus 2 times x minus 1. And we know our a has to be negative. It didn't have to be -1. It could have been -2, -3, whatever you like. Okay, and so that's like our main idea of what we're talking about today. So they're going to give us some information. They're going to describe our polynomial, and we're going to do the sketch. So we know here that this polynomial is third degree with a positive a value. So we know that our end behavior is going to be down, up. The other thing we know is that there are 3 x-intercepts. They don't have them as repeated roots, so they're each going to just have us cross through the x-axis, no tangents. So here, when I do my rough sketch, I have x-intercept at -1, an x-intercept at +1, and 4, and I'm going to just chop through. Now, if we wanted to think about a possible equation for this, we have some a value that needs to be positive, and we're going to swap our sign. So if I cross through at -1, the factor was x plus 1. If we cross through at +1, the factor was x minus 4. Same thing for the +4, the factor is x minus 4. Now, we really need to know what a value we're going to use, and that's going to be kind of what we talk about today. So when we talk about the roots form of a cubic equation, the general form is y equals a times x minus the first root times x minus the second root times x minus the third root. And then, of course, we need to talk about things that are higher degrees. So on the next page, we talk about that. We have a little summary up here. So if I add in a 4th root, that means I'm adding in another factor. So it's the same. Here's where we ended for a 3rd degree. And if I'm a 4th root, well, then I need one more factor. And then our 5th degree, same exact idea, but now I'm going to have another factor, so I'm going to end up with 5 factors. Now, the very next thing is I say nth degree. That means, some higher degree. I'm still going to keep the same format. It's just my very last one. There'll be n of these. Okay, so here we're going to use this idea and we're going to work backwards from the roots they give us. So write an equation of a cubic function. So if it's cubic, I know that it's going to be something where it's this, and has the potential to have 3 parentheses. So if I have a root at -2, I'm going to write my first set of parentheses as x plus 2. Now they tell me it has a multiplicity of 2. So that means I'm going to write this as x plus 2. Again, it was a repeated root. And then my next root was 5, and they told me it had a multiplicity of 1, so it should only happen once. Now, I don't know my a value. However, they give me a point that's on this cubic. So I can plug in the x and the y from the a value, from the problem, and solve for my a value. So I'm going to plug in 16, and I'm going to plug in -3. And I'm going to multiply this out. So this is -1 times -1 times -8. So this ends up being, we plugged in 16 for that. 16 equals -8a. So that means my a is -2. So my final form for this is y equals -2, x plus 2. If you want to get fancy, you could write it squared since it's repeated, and times x minus 5. I'd like you to use this same idea and think about the fact, remember, this means if it's not touching the x-axis, it's tangent, or touches but doesn't cross. Use the same idea to try to write the equation for number 5. So I want you to pause the video. Okay, at this point you've tried it. So here, if we look, they gave us a point. We're going to use that as our x and y to plug in to find a. They tell us it's 4th degree, so we know we should end up with 4 factors. We have roots at -1 and +1, but both roots are spots where it's going to be tangent to the x-axis. It doesn't actually cross, so we know that those are repeated roots. So when we go to set this up, we're going to say x plus 1 and another x plus 1. You can get fancy and write it squared. Same thing with the x minus 1. I'm going to substitute in my -9 and my -2. And I'm going to solve for a. So I'm going to skip the algebra here and just go straight to telling you a is -1. So my final equation here would be y equals -x plus 1 squared times x minus 1 squared. Okay, so for homework, I'd like you to try number 6. I gave you the graph. A hint to you is you want to try to identify what your x-intercepts are to work backwards to find the factors, and I would use the point of the y-intercept to help you out.